Hi everybody. So today for our Tuesday live stream, we're going to talk all about combustion reactions. So before we get started, we're going to talk about our sponsors. There's Actua and NSERC. Without those guys, we wouldn't be able to do the live streams, give out the activity kits, and do everything we do here today. So before we begin, what is a combustion reaction? So most people think of it when something is on fire or something's burning, which is right. There's three components to a combustion reaction or to a fire. You need fuel. So if you think about a campfire, it's the wood or the timber. You need oxygen, which is all around us in the air, and you need a heat source of some sort. So that could be like a spark, or it could just be pure heat. There's also two types of combustion reactions. There's something called a complete combustion, which the example here shows that it produces carbon dioxide and water. So that'd be like smoke and steam that comes off of your fire. And then there's something called an incomplete combustion, which also produces water and carbon dioxide, but there's another thing it produces, carbon monoxide, which if you've heard of it before, you've probably heard of it as the colorless, odorless killer, because it's a toxic gas that you can't see and you can't smell it. So we don't want incomplete combustions. So before we start doing any experiments, we want to talk about safety. So as you can see, I have my lab coat on, and I'm going to put my safety goggles on before we begin. And it's also good to say that you don't really want to try these experiments at home unless you have someone supervising you. And even then, it might be a little too risky to do these at home. So the first experiment I'm going to show you is something called the exploding gummy bear experiment. So we're just going to full screen the PowerPoint here so that you can see the video a little bit better. Now, the reason that we're showing this in a video instead of actually doing it for you today is because it requires special circumstances. It needs to be done in a fume hood because the gas it produces can have contaminants in it and be dangerous for us to inhale. As well, as you can see, it lights up a lot. It produces a lot of heat. We're just gonna let the video load in a little better. And what you're seeing here is inside this tube, we took potassium chlorate, which is a salt. We heated it up with the torch until it was molten and it was a liquid. So we changed the state of it from salt to liquid. And then we dropped a gummy bear inside. And when the gummy bear is dropped into the potassium chlorate, it reacts and creates a combustion reaction. So this is a complete combustion reaction. It produces carbon dioxide and water, no carbon monoxide. But again, it's in the fume hood just in case. And what happens is we all know gummy bears have a lot of sugar in them. And sugar has a lot of oxygen in it. So when it reacts, or when it is dropped into the molten potassium chlorate, some of the oxygen can come off of the sugar and add fuel to the fire or this combustion reaction. So like I said, potassium chlorate is a source of oxygen as well as the sugar. And then after heating, it decomposes into oxygen and KCl. So the next experiment we're going to do, we are going to show you how to do it. But again, do not do this at home unless you have parents helping you, or maybe your parents can show you how to do it at home because it is a really neat experiment. So basically what we're going to do is we're going to take some steel wool and we're going to light it with a 9-volt battery. So I'm going to give you a better look at this. Try to get a good angle so you can see really well. Okay, so this is steel wool. This is super fine steel wool, so when handling it, you need to use gloves. And I'm going to take a 9-volt battery and show you how to light it. I don't need gloves on right now because I'm not actually going to touch the steel wool, but when I do it a second time, I will have to put them on. So I'm just going to take a 9-volt battery, just a regular battery here, and all I have to do is touch the steel wool with it. It kind of looks like a bunch of little ants is a good way to describe it, because I know the video quality isn't perfect. You can see it's still going, the reaction's still going on. And I can keep touching it a couple times. You can kind of see the color change, but that's because of what reaction is going on. But there's parts that are still like the light gray color, which you can touch again with the battery and set them off again. So the reaction is pretty much done. Don't see any more sparks flying, so I'm just going to move this and fix the camera. So that is the burning steel wool experiment. So the funny thing is about this experiment is it's not technically a combustion reaction. So just because something is burning does not mean it's combusting. So with the steel wool, try to think about an incandescent light bulb. If you look at an incandescent light bulb, if you still have some in your house, there's a little wire inside of it. And the light actually comes from that wire heating up really, really hot. And then that heat can also give off light. So here, it isn't producing water and carbon dioxide, or carbon monoxide, carbon dioxide, and water. It's actually oxidizing the steel wool, which means that it's basically rusting. And that's why you can see the color change in the steel wool. It turned from that light gray color to that dark gray color. So basically, by hitting it with the 9-volt battery, you're causing a current to go through the steel wool, because it's iron, you know, it's like a wire, a current can go through it. But because it's so fine, it just causes it to burn, and it causes it to react with the oxygen to oxidize it. So it's a really experiment, and it doesn't need a lot of materials. So the third thing that I'm going to do for you today is we're going to be catching something called lycopodium powder on fire. And some people like to consider this experiment the fire breathing experiment, because it looks like you're breathing fire when you do it. So my friend Callie, she's going to pivot the camera so that we can go to where the setup is, because it needs to be out of the way of anything that is flammable. So it looks like the camera is good now. So as you can see here, I have a stand with a clip and a candle. The candle is going to be our fire source. Then I just have a wooden block here to catch where the candle, like in case the candle drips wax. So I'm going to light it. It's been old, so it might take a second. There you go. The candle's lit. I'll move this over here. And we're going to be using the lycopodium powder, and basically we're going to blow it through the fire, and you're going to see something happen. So I got a tubing here with a funnel. I'm going to take the lycopodium powder and drop a little bit into the funnel here. Move this aside because it's flammable. We don't want that in the way of the fire. And then all we have to do is blow into the tubing, which is going to shoot air out and cause the powder to launch through the fire. And then you're going to see what happens. Did you see it? I'll do it a couple of times because sometimes it's easy to miss. It happens so fast. And sometimes it doesn't work at all. But that's okay, because we have more powder right here. So that was a really good one. The more powder you use, of course, the bigger the explosion is going to be. And then the harder you blow, the further it'll go. So it's a really neat experiment. I was just using the rest of the powder there. And it's really neat why this works too. So I'm just gonna blow the candle up. We don't want that to stay lit. We're gonna move the camera back. So I actually have a slow motion video here. Excuse me. For you to see. I'm just gonna let it load in because, as you know, the last video didn't load in properly. Just gonna let it load in a little bit. So it's just a neat way to show how the fire kind of works its way through the powder that's in the air. So it's really important that you launch the powder into the air. So lycopodium powder, as you could see, was highly flammable, which just means it's easily set on fire. So it's made from the spores of something called club moss. So it's organic. It's, as you can see, like I was blowing through a tube. It's safe to ingest a little bit or whatever. Just have to make sure that you drink water afterwards or rinse your mouth out. So lycopodium powder has a very high fat content and it has a very, very small surface area. If you want, I can show you the powder up close so that you can see it's very fine. It's finer than sand. I don't know how well you can actually see it, but it's a very fine powder. Like it almost behaves like a liquid. It's so fine. So yeah, and so with the small surface area, it's really easy for it to catch on fire, but only if you disperse it in the air. If I just had a clump of it and I tried to take a match to it, it would not light on fire. It has to be dispersed through the air so that it can interact with oxygen so that the fire has one of away and answer anything you're wondering. And while you're doing that, I'm gonna light the other steel wool on fire. So I'm gonna put on a glove here. Like I said, when you're handling super fine steel wool, you want to put gloves on because the little particles can get into your skin. So we're just gonna angle the camera down again. Going to pull the steel wool apart. Okay. I'm going to take the glove off just so it's a little easier to do. See what I'm doing? So while that's going, does anybody have any questions for me? Or do you want to see me? I can use the lycopodium powder again if you want to see it again. It is a very cool experiment, so I understand if you want to see it again. There's also a delay between when you ask the question and when I receive it. So if you have already asked something and we just haven't seen it yet, we will see it shortly. All right, if there's no questions, that's the end of our stream today. Tomorrow and the next day we have them again. And then next week will actually be our last week of live streams. So make sure you join us while we're here at 10 a.m. every Tuesday, Wednesday, and Thursday. Thanks for joining.